This video is about dividing rational expressions, and this is very similar to multiplying rational expressions. Instead of just multiplying straight across, however, remember when we divide two fractions, we have to multiply by the reciprocal of the second fraction, and the reciprocal is a fraction flipped upside down. Our first example A is negative 4k squared over 4k to the fifth divided by 16k to the fourth over 12k to the sixth. Usually I like to simplify everything first. With the k's though, we're going to actually do the multiplications of them first and then simplify later. I think it's easier than crossing a bunch of things out, and it just gets really messy if you try to do that. So we have negative 4k squared over 4k to the fifth. And then it's going to be times, so we change it to multiplication, and then we have to flip this second fraction upside down. So we'll write the 12k to the sixth on the top, and the 16k to the fourth on the bottom. Now we have 4 divided by 4, so those will cancel. And we want the number that will divide both 12 and 6, and we want to pick the largest one if we can. And the largest thing that divides both 12 and 16 is 4. And so 12 divided by 4 is 3, and 16 divided by 4 is 4. We have this negative sign that needs to come through. And then for numbers, we have 3 on the top and a 4 on the bottom. On the top, we would multiply straight across. K squared times k to the sixth is k to the eighth. And k to the fifth times k to the fourth is k to the ninth. And I just think it's easier to do the canceling with the variables after you do this multiplication than it is before. It's just a lot easier to keep track of this way. So we have 3 on the top and a 4 on the bottom. There are 8 k's being multiplied together on the top and 9 k's being multiplied together on the bottom. So all 8 of these will cancel with 8 of them on the bottom, and so we'll be left with 1 k on the bottom. Our answer then is negative 3 over 4k. Example B, we have 2 minus 2x over x divided by 5x minus 5 over 3x squared. We need to factor everything, and notice we have a number minus a variable part here, and here we have a variable part minus a number. So here I'm going to factor out a negative 2 instead of just a positive 2, because I really want this x to be positive. Remember, when we factor a negative 1 out of something, it switches the subtraction. And so we would have negative 2 plus 2x. And so that would be negative 1. And then we can write the positive 2x first. And then the negative 2 means we have minus 2. And so when we factor a negative 2 out, then we'll really be left with, so it's like factoring a 2 out of this here. So we would have x minus 1 in our parentheses. And then that's over x. We're going to change this to multiplication, and in the same time we're going to flip this fraction upside down, so that's 3x squared on the top. And on this, 5x minus 5, we can factor out a 5. And that will become 5 times the quantity x minus 1. We can cancel the x minus 1's. We can also cancel this x with one of the x's here, so we'll be left with an x on the top. Again, we have a negative sign here, so it's going to be negative. And then 2 times 3 is 6. And we also have an x on the top. And on the bottom is all we have left is this 5. Our answer then is negative 6x over 5. Example C, y squared minus 11y plus 30 over y squared minus 36 divided by y squared minus 9 over y squared minus 3y minus 18. We need to factor everything and also change our division to multiplication by flipping the second fraction upside down. We need to factor 30 so that the sum of the two factors will give us negative 11. And we can factor 30 as 5 times 6, and we want a negative 11 in the middle, so it's going to be y minus 5 times y minus 6. Y squared minus 36 is the difference of two perfect squares, and that will factor as y minus 6 times y plus 6. And then change the division to multiplication, and we're going to flip this upside down, so I'm going to look at the denominator first. I need to factor negative 18, so the sum of those two factors will give me negative 3. That will factor then as y minus 6 times y plus 3. Now the y squared minus 9 is going to go in my denominator, and that's the difference of two perfect squares, and that will factor as y minus 3 times y plus 3. Now we're going to cancel anything that we can cancel. We have y minus 6's on top and bottom here. We have y plus 3's top and bottom here. And that's all. There isn't a y minus 5 on the bottom, and there's no y minus 6 on the bottom. And there's no y plus 6 on the top, or a y minus 3 on the top for us to cancel. On the top, we'll be left with y minus 5 times y minus 6. And on the bottom, we'll be left with y plus 6 and y minus 3. So you can't cancel unless they're exactly the same. So this y minus 6 cannot be canceled with this y plus 6. Those both are different and need to remain. Our last example here, 2k squared minus 8k plus 6 over k squared minus 9 divided by 4k squared plus 18k plus 14 over 2k minus 6. We need to factor everything, and right on the top here I'm going to do the first little factorization because notice everything in this top, 2k squared plus 8k plus 6, we can factor a 2 out of that. And we'll have 2 times the quantity k squared plus 4k plus 3. So we'll have 2 times, we want to factor 3, so the sum gives us 4. That'll be k plus 1 times k plus 3. And our bottom is the difference of two perfect squares. That factors as k plus 3 times k minus 3. Turn the division to multiplication. So the new top is going to be the 2k minus 6, and we can factor a 2 out of that. That will be 2 times the quantity k minus 3. And on the bottom, we'll put what used to be on the top here. And everything here can be divided by 2. We would have 2 times the quantity 2k squared plus 9k plus 7. And now this is a good candidate for the guess and check method because there's only one way for us to factor this 2k squared. It's going to have to factor as 2k and k. We just need to figure out where to put the 1 and the 7 because there's only one way to factor 7 as well. So I'm going to put the 1 in the first set of parentheses and the 7 in the second and see if I got it right. So when I do my FOIL from the inners, I'll get 1k, and when I do the outers, I'll get 14k. We need a 9k in the middle, and this will give us either a positive 15 or a negative 15. So I have my 1 and my 7 in the wrong place. So I'm going to switch those. Put the 7 in the first set of parentheses and the 1 in the second. Now when I do my multiplying for FOIL, I'll have 7k in the middle. Oh, let me fix my k. And when I do the outers, I'll have 2k. And this will give me the 9k that I need, and I need a positive 9k, and I also need a positive 7 when I multiply, so both of these get a plus sign. Just neaten that up. Now we do our canceling. We have a k plus 1 on both the top and the bottom. We have a k plus 3 both on top and bottom. And we have a k minus 3 both top and bottom. And we have a 2 top and bottom. All I have left on the top is a 2, and on the bottom I have 2k plus 7. And we can't factor anything else or cancel anything else. And that concludes our lecture on dividing rational expressions.